Hey, 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 what's up, everybody, and welcome to a new episode of Data Trends. Today's lesson, from today, there will be, I think, 4 to 5 lessons on machine learning. I wanted to make this video since a long time because I was doing some machine learning algorithms before, but then, in the current company, I never have opportunity because it depends on the mentality of people also and depends on projects also. So I don't get an opportunity to do any machine learning stuff there or do any classification, etc., etc. But anyways, this is me and my YouTube channel, and where I talk about a lot of things regarding personal blogs, what's happening in personal life, then regarding data, regarding blockchain, regarding crypto, a lot of things I discuss about. So please do like and subscribe my YouTube channel. And regarding VTHO, let's forget about that because the market is not good, and I'm pretty not. I'm not happy that much about my portfolio. So we'll discuss about it in the next VTHO episode. Okay, so there are a lot of things stacked up for this playlist. Means I'll be discussing the entire or the main components in the machine learning community. What are the type of algorithms are there? Then those algorithms I will showcase some sample solutions in Python, and we'll talk about many cool stuffs other than that application mechanisms. And if you have some queries, then you can also post. Okay, so the first part, this is the first part, and the first part I will be talking about regression. But let's see what we should do with the data set before even thinking of applying machine learning. Well, as in the previous episode, I already discussed about data engineering and its importance and what happened to data scientists, because this current era is of data engineering, because in earlier years, people, when the machine learning and AI was new, then people spent, or the company spent billions in implementing those algorithms. But as we already know that many companies are suffering or struggling with the basic data, and when the basic data is not good, then these algorithms will give only biased results only, or erroneous results. So first, the data engineering has to be correct. Data has to be very clear and crisp, without any errors, or without any means it should be like, it should be very nice, or it should be up to the mark to apply any machine learning algorithms on it. So before even thinking of applying machine learning, please check the data, check for covariance, check for linearity, apply descriptive statistics, apply quality measures, remove the nulls which are not needed or can prove to be erroneous in the while creating the models. Means a lot of things you can do. I have my previous videos on data. Please do see these the videos there where I talk about data quality. I talk about data extraction. I do talk about a lot of things. If you have any questions, then please fill me in. Okay, so these are the preliminary things that one can do in before applying machine learning algorithms. But coming to machine learning algorithms, well, I think machine learning module is not difficult if one is involved in data, not those wannabes who think that they are data analysts. Because I see many people in my day to day life who think that they are data analysts, but they are not. And yeah, if you are a little bit good in statistics, and if you have little bit knowledge about how to make the data quality good, how to apply analytics on it, or how to check different attributes in the data like linearity or covariance, then I think machine learning will be like easy for you. In machine learning algorithms, there are two classifications, or two criteria, or two subcategories, that is supervised learning and unsupervised learning. We will discuss about each in detail in this playlist. So buckle up your seats. Uh, so if I have to explain supervised learning, Well, there is a data input that results in an output, like a independent, dependent. If you know y equal to mx plus c, independent and dependent variables, and calculating the betas and etc. etc. So, in short, those type of groups comes under supervised learning. In unsupervised learning, you draw inferences from data inputs without references or without any info of given outcomes. Like y equal to mx plus c, you don't know about y from the beginning, then mx plus c, you have to draw inferences out of it of the likelihood of the output, or the y, or the independent variable. So, in short, you can also Google supervised and unsupervised learning. You will get a lot of definitions out of it. A lot of people talk about that. I'm not new. Yeah, supervised learning. Well, supervised learning can be further subcategorized or subgrouped into regression, classification. Let me highlight it: regression, classification, clustering, and dimensionality reduction. We'll go each in detail. Don't worry, guys. I am going to walk you through. I'll spoon feed you with ready-made codes and some results also, so that you can enjoy and you can see how these things apply. These are not rocket science. This is just that we didn't study all these things. We didn't get the opportunity. Company people are not matured enough to think about all these things. It's just the little bit of unluckiness and little bit of lack of opportunity. So I am filling up the gap. That's it. Regression. So regression y equal to mx plus c, that is regression. Regression can be divided into linear regression, non-linear regression. There can be thousands of things. In supervised learning, we have linear regression, and in linear regression we have two elements, that is sorry, multiple linear regression or polynomial regression. Polynomial regression are like logarithmic and you try to fit in. For example, if you take Excel, if you want to do a scatter plot, let's take insert. I want to do a scatter plot. Okay, so if I want to try to find a linear regression out of it, if I want to find a trend line and linear, okay, if I want to try to fit this one, display the R squared value, display the equation. If I want to fit in this one, excuse me, something like this, we will see. Okay, this is so if I want to fit the model, I can move to 2 degree or 3 degree of x. I can do a lot of complex stuff here. So this is something like uh, polynomial means finding a curve of best fit, that is the nonlinear regression part, and finding a plane of best fit means if we have it's multiple linear regressions, like for example x1, let me write it down, y equal to beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus c. Okay, so this is called, means there are three independent variables, and this is called multiple linear regression. You cannot simply use Excel to find the components of betas and find the best fitting line and find the independent and dependent variables also, or predict something, because if I have to do a scatter, because with one column of data, finding a scatter plot, finding the plot, and finding the fitting line, as well as finding a Finding an equation, a trend line for it is easy. But if you have multiple variables and if there is a big data, then you need something like Python to execute the linear regression or multiple linear regression there. Okay, so in today's video, we will be covering only these two elements. So let me highlight this one. And in the further videos, will means I will then the second video will be on decision tree, random forest, maybe neural network. I will skip it because it is too complicated for me to go into the details, and so on, so on. Okay, let's cover these two. Uh, I have a data set that is a random data set I created with, you already know this one, right? In Excel, rand between, and I took from here, means I created a data set here. And this is like beta 1 x1, beta 2 x2, beta 3 x3, and the result. Intercept part, I have left it to or be automatically calculated in Python. So we'll see that. And this data set, this is like a data set of 104 means 1,048,576, and from here I will divide a test data set and training data set, and after that I will apply the model to it to on the training data on test data set to do some predictions. Okay, and the library that I will be using for the entire or the majority part of the machine learning is sklearn. Sklearn is means like scientific kit learning modules. It's ready made, and from sklearn I'm importing the linear model, and there are two methods to create to create multiple linear regression models. One is by stats model and one is by sklearn. So we will be using two methods. What I have done here is that the machine learning Excel sheet, I have given a read Excel command here, and I am reading the sorry, I am reading the files here. It means I'm reading the file here to extract the data. Then each, I mean, for now, means this laptop is of 8 GB RAM, so I don't want to over burden it with a lot of data analytics. So I have taken only 100 set of data, and these are beta 1 values. This is the column name, as you saw already previous in the a few seconds back. Beta 2 is the column, beta 3 is the column, and my result set is stored in the Y. So these are X and these are Y. Here, the sklearn is has made life very. This library has made life very easy. So you just have to write, by importing the linear model, you have to just write one single command, that is linear regression, and fit the X column X, the independent variable, the dependent variable, and the independent variables in this regression fit, and then you have to use the predict command here. So after using the predict command, it will this is what the full sklearn algorithm looks like. Means the multilinear model is now done with these three set of commands, and that's it. But people, though I have been working with this, so I know for me it's a white box, but for many people it will be a black box, because how this sklearn is working and blah blah. So you don't have, maybe if in the company the project is simple enough, then you don't need this, because if the model is fitting is around 90%, then the model is correct, and you can use that model for the predictions. But if the model is 60%, then the R values are like 60%, then you have a problem, because the model is not fitting enough and you cannot apply or use that model to predict further. There are some pros and cons of this model, because if there is discipline in the data, then you can use the model that you will receive from here to predict for the new data sets. But if there is some very high variance with the data set, then you cannot use, because the model is only, it's like garbage in and garbage out. So the model is only fit to some means some data sets only, but not all the data sets, because there is no homogeneity in it. Please search for the word homogeneity in, because in statistics homogeneity means the data samples are homogeneous. If the data samples are not homogeneous, then the model is of no use. Okay, I am printing the coefficients here and the intercept, like x1, x2, x3 beta means the fitting beta values, and the constant there, the unknown constant there. So because that is the whole model of mine, then I can use or apply that on the test data set to further fit the model. Then that is the scale-on approach. Then I already said that I'm using second approach, that is start model approach. In the start model approach, I'm using only these three lines. Yeah, to add the constant, then SM.OL fitting, then to predict. That's it. Then after that, I will run the whole algorithm, and it will give me some results, and I have to interpret those results. If the R-square values are less, then there is no point in further moving on with the model. Then I have to tweak the data set, or I have to tweak, or I have to apply some advanced multilinear regression techniques like add-ons to this algorithms to get a proper fitting model, or I have to approach something else. I hate 8 GB RAM laptops for sure. I hate this because to process only 1 million records, this is what the condition of my laptop is. But I have, please do check my other videos where I have created my own PC for big data processing. So here you can see my my 32 GB RAM Ryzen 9 5900X PC, where I process big data and I prepare these codes there only. Then I import it to this laptop for just demonstration purposes. Okay. Meanwhile, let me start with poly, because I will be. Let me go back to the slide. So we saw how means how the code looks like. It's very easy. sklearn gives ready-made options to apply and get the results. So, but if you have to go deeper, then you have to check all the codes in detail. Okay, we'll go to the polynomial. Okay, the results are already out. We'll go to the polynomial regression technique, and I have to install matplotlib. Okay, meanwhile, when this is getting installed, so let's see what the result is. Okay, so the beta one from the sklearn technique, or sklearn approach, the beta 1 is minus 60, beta 2 is 0.05, and beta 3 is 29. I can do sensitivity analysis further, and the coefficient is 254. So this is what the result I got from the sklearn approach. And from the stats model approach, very bad R value I have got. So this model is super bad, and AIC log likelihood, all this, yeah, these results are not good. So maybe I will be not using this model for the testing purposes or for the on the new data sets. So if you can see, minus 60.95 and minus 60.95. So the beta values and the constant value are the same from both the approaches, the stat model approach and the sklearn approach. So, and the standard error is very high, and the t value is also high. So, but overall, this is what I wanted to show. In maybe I created the data randomly, so maybe that is not the right way to collect the data. So please excuse me for that. And but okay, anyways, if you have a good data set, then please use the technique. The codes will be available in my GitHub, and the GitHub link will be given in the description box. And yeah, that's it for the multilinear regression. Okay, for the polynomial, finding a curve for best fit. The model is also, or the algorithm is also very small. I used only, let me change. I am using PyCharm IDE for running the Python, and the Python this is the interpreter is Python 3.10. So what I have done, I have taken it. I kept the example very easy. I could have taken my earlier dataset also, but this one I have kept it very easy. I have x and y, and the independent variable is y. X is a dependent variable, and sorry, no, not the independent dependent variable here. I just want to fit a line, and I'm using the 3 degrees of freedom. Sorry, I forgot about this because I wrote these codes a long time back, and yeah, I didn't see the again that much. Okay, my degrees of freedom is 3 here, and I'm taking a 2 data set, means x and y here, to fit the model. Let's run the model to see how it looks like. So this is how it looks like. So with the y and the x, I have means the x and y value, x and y data. I have scatter plotted. Then I try to fit in the model here to represent this data set, and the degree of freedom is 3 here, which means it's like x to the power 3 or something. So it's a nonlinear model, and I'm using okay. Then I used matplotlib to plot it. I should have also shown the equation here. What is the equation here? But guys, this is how you use the polynomial linear regression. With, I can also mention the degree of freedom here. For example, if I make it 5, then if I run it, so this is how it looks. If I close it, okay. So here it. So this is how the model looks like. Okay, I am printing the model here, and this is to fit the line within the among the scatter plots. And the model is like minus 0.000131 x to the power 5 minus 0.009065 x to the power 4. So it's a nonlinear regression model, or you can say polynomial linear regression model, and I have a constant here, and I could have also checked the accuracy and what is the R square value and everything, but I didn't do. But you can do it. There are a lot of codes available online. You can do it. Okay, so I think I have come to an end of this video. So for the first component, that is regression, we covered linear regression types, that is multiple linear regression and polynomial. In the current world, multiple linear and polynomial regression are widely used. So if you are a master of this, then I think in uh, most of the problem statements, you are already way ahead than many people. Rather than simple analytics, you are doing linear and non-linear regression both. With that being said, have a nice day, guys. In the next episode, we'll be checking on decision tree and random forest. Please do like and subscribe. Please help me, guys, to grow, because it really motivates me to further make this kind of videos. Okay, have a nice day, guys, and we'll see each other in the next video.